In this lesson, we're going to talk about the intersection and union of two sets. There's a really nice little summary here on this first page. You should spend some time reading that. But let me give you a really quick example of this using a Venn diagram. If we have two sets and we say that, let's call this numbers 1, 2, 3, and here's 4, 5, 6, 7. Let's just say that we have these two sets and we'll call them A and B. Then what would be set A? A would be set 1, 2, 3, 4. B would be 4, 5, 6, 7. If you wanted to do A, now what's that symbol? Is that union or intersection? Okay, that's intersection. A intersection B. This means where are the two sets the same? What value is in both sets? In this case, it's only going to be 4. On the other hand, if we have A union B, then this is going to be all of the elements that are in either of the sets. So here you'd have 1, 2, 3, 4, 5, 6, 7. Okay, so what I would do on your cheat sheet is I would come up with another way of describing these two symbols. You know, intersection and union might not be your favorite. I like to think of this one as AND, so which set is in A and B, and then I like to think of this one as OR, which one is in A or B. Okay, so we need to get a handle of that. Let's look at some more examples. Here's a set of cards. By the way, if you're not familiar with cards, you can always ask about that. Information like that should not keep you back on a test, so if you need to ask, please do. Okay, describe the sets for this. Well, the universal set is going to be all the cards. Okay, there are 52 cards. Okay, on the other hand, set C is going to be all of the clubs. Set S is going to be all of the spades. Set H is going to be all of the hearts. And D would be all of the diamonds. Okay? And they're in that order, by the way. Here's clubs, here's spades, here's hearts, here's diamonds. Okay, describe NC. So, how many cards are in that set? Well, 13. In fact, they're all 13. Okay? And S is 13, and H is 13, and D is 13. There are 4 sets of 13 cards. Okay, describe the union of S and H. Okay? Well, the union of S and H is that or and. Union means or. So we're looking for all of the cards that are in either spades or hearts. Okay? So if we wrote that, it would be all cards in the set spades or hearts. If we looked for NS union H, that's the N of S, or, and when you have R or, you use plus, which is kind of weird because you'd think and would be plus, but that's or. So this is going to be 13 plus 13, which is 26 cards. Okay, describe the intersection of S and H. That's all the cards that are in S and H. In spades and hearts. Are there any cards that are in both sets? Well, no. Okay, the number of spades and hearts, oops, and hearts is 0. In fact, that set is an empty set. Okay. Determine whether the events that are described by sets S and H are mutually exclusive and whether S and H are disjoint. Well, what do you think? If there's no elements in them, they are disjoint and therefore they are mutually exclusive. Okay, so S and H are disjoint, meaning nothing's in common, because they have no intersection, and therefore they are mutually exclusive. Okay, what's the complement of SUH? Okay, SUH. And we're going to say what's the complement. Okay, so this would be not spades or not hearts. So this is going to be the clubs or diamonds. Okay, and this is the set CUB. Okay, let's try another one. So here you have some sports. I would say if this was a test question and you weren't familiar with one of the sports and you wanted to know something about them, you would be able to ask that. Okay, so it says determine the number of sports that require the following types of equipment: a ball and an implement, such as a stick or club or racket. Only a ball, an implement but not a ball. Okay, before we do that, there's basically two kinds of sets that we're interested in. Okay, so let's write those. First of all, the universal set is all sports offered. So just the sports in this list. Okay, and then we have two sort of subsets. These ones use a ball, and then we'll use I to say use an implement. Okay, so why did I choose those two subsets? Well, they're the ones referred to here: implement ball, etc. Okay, so that's why I chose them. If they would have said helmet, use sports which use a helmet, I would look at the subset using a helmet. So let's take a look. Badminton, what does it use? No ball, but it uses an implement. How about basketball? It uses a ball. Cross-country running, neither of those two. Curling, I guess the broom's an implement. Football is a ball. Golf uses a ball and an implement. Hockey uses an implement. Lacrosse uses a ball and an implement. Rugby, a ball. I guess that you could say that implement, but I don't think that quite. I think there's a little problem there with my mic, so I apologize if that sounds kind of bad, if there was a lot of background noise there. We were with cross-country skiing. I think you could argue that the poles might be an implement, but when you look at either a stick, club, or a racket, I don't think we're going to say cross-country skiing has an implement. Soccer has a ball, softball has a ball and a bat. Tennis, same thing, ball and a bat. Ultimate has neither. Volleyball has a ball, and wrestling has neither. Okay, so first question A says, determine the number of sports that require the following types of equipment: a ball and an implement. Okay, so just before I do any of this, let me quickly mention that the number in the universal set is 16. The number with ball is 9, and the number with an implement is 7. Okay, so we know that there is 16 elements in the universal set. There are 9 in using a ball. There are 7 in using an implement, and there are 4 that use neither. I got that by looking here where there's nothing. Okay, so let's just figure out where that 4 is. 4 should go here. This 4 right here. Neither. It doesn't fit into the set. Okay? Now here's the weird part. If I take 9 uses a ball, 7 use an implement, and 4 don't use either, this is 20 sports, but only 16 sports offered. So this means we've counted some twice. We must have counted 4 of them twice. That's got to go right here. Okay, and if you go and check, you'll see there are actually 4 that use implement and the ball. Okay, so if there are 9 that use a ball, but 4 of them also use an implement, 5 must not use an implement. Okay, so this is, because there's 9 in total, take away the 4, that's 5. And if I do this, there are 7 in total, 4 are in this union part, intersection part, that means there must be 3 here. Okay, so that's A. Continuing, let's figure out what B is. B is the number that use a ball, not an implement. Okay, well, we just figured that out. That's the number that use the ball. Take away the number that use ball and implement. So this is 9, take away 4. Okay, so let's try and do the same thing for C. C says an implement but not a ball. So the number that use an implement, not a ball, is the number that use an implement. Take away the number that use a ball and an implement. Okay, so here we have 7, take away 4, which is 3. Okay. Now there's a few more questions still. Let's quickly talk about the principle of inclusion and exclusion. The number of elements in the union of 2 sets is equal to the sum of the number in each set less the number in both sets. This should make quite a bit of sense. I mean, just looking at this, if I want to know how many are in both sets, I'm not going to count 4 twice. It's not 9 plus 7. Okay? So there's a fancy way of writing this out. If I want to know the number that's in the implement or the ball, I take the number of the implement plus the number of ball, take away the number of the implement and ball. So this is 9 plus 7, take away 4. This means there's 12 in total that use one of the two, either the ball or the implement. Could be either. All right, that's how we find the number. Now, if I want the number of implements or the ball and not that, so this is, we're going to use neither the ball or the implement. Okay, this is the number of the universal set. Take away the number of the intersection, implements or ball. So there were 16 in the set, there were 12 that used one or the other or both, meaning 4 don't use either. Okay, so that's, I mean, this is kind of weird. We've got this notation here, but you could probably answer the question just by looking at the Venn diagram. Okay, so we need to be able to use both because sometimes we have to do the fancy writing. Okay, let's try another one. Same kind of question. Jamal surveyed 34 people at the gym. He learned that 16 people do weight training. So let's write some of these sets. N of the universal set, there's 34. N of using weights, there are 16. N of using cardio 3 times a week, there were 21 people. And then N, now what's the last one? And 6 that train fewer than 3 times per week. Okay, so this is this would be, I guess, not training 3 times per week. So this is not doing weights or cardio. Oops, cardio. And we want to say not. The number that don't do either. This is 6. Okay? So let's try to put this all in here. First of all, the universal set, there are 34 in there. Okay? Well, now where does everything go? I can't just say this is W and put 16 there, and I can't just put 21 here. What I have to kind of figure out is how many of these were counted twice. Okay? How many people did both of these activities? Well, let's add up these three. If I take 16 plus 21 plus 6, I end up with 43. So that would mean there were 43 people surveyed, but there were only 34 people surveyed. So if I go 43, take away 34, this gives me 9 people counted twice. Nine people counted twice means 9 goes there. Okay? So now I can figure out these other ones pretty quickly. I know that there are 16 people that do weights. If 9 of them did it, were counted twice, that means 7 weren't. This one, there were 21 people that did cardio. 9 were counted twice, means there were 12 that weren't. Okay? And let's quickly add that up. 7 plus 9 plus 12, that's 28. That leaves me with 6 that did neither, which is what we have. Okay? Alright, I'm going to pause there. We'll break this lesson into 2. There is another question, but we'll leave it for the next video. I will